This is the video demonstration to show the details about the code. My name is Leo, and I'm going to show how I completed assignment 1. According to the assignment 1, there are two main classes, vertex and directed graph. In this case, the vertex contains vertex ID and the weight of the vertex. Then there is a less than sign operator, which will return true when the vertex weight is less than another. In the class directed graph, there are two different data structures. One is the vertex list and another one is adjacent list. Vertex list is a list that contains all the vertices and their index. As you can see, the first variable is linked to the vertex list, and the second variable is a virtual vector, and the weight of the vector has been treated as the weight of the age. And now I will introduce the methods. There is a constructor and a destructor. This is to prevent the data from being disturbed by the previous memory. We can easily check whether the graph contains a specific vector by using the function find. This is used to compare and traverse the specific vertex. It will return true if there are specific adjacent vertex, otherwise it will return false. This method is to add new vertex. And this is for adding a new edge between two vertices. When I review the code, there is an invisible bug. I didn't find it because the mark system did not notice anything. To be specific, when removing the vertex from the vertex list, I should also delete it from the adjacent list at the same time, but I didn't do that. This may lead to data redundancy. This is how to remove the edge. Just traverse all adjacent, and if there is the same vertex, then just remove it. This is how to count in degree. Traverse all adjacent lists. If there is a UID, then the amount will be added up. Finally, it will return the amount. The size of the adjacent list is equal to the out degree. Adding up in degree and out degree to show the total degree. Just return the vertex list size to show the number of vertices. For the total number of the edge, just traverse all the adjacent lists and add up all the size. For the get vertices, just rebuild the vertex list and return the acceptable format. Just return the adjacent list of the UID to get neighbors. This is the way to get the second neighbors. In this case, we want to get the second neighbors of the fourth vertex. Firstly, we get neighbors of 4. And then we get 3 neighbors, 1, 3, and 5. After that, we get a neighbor of 1, so we get 2 and 3. And we add 2 and 3 to the second neighbors, and the vertex 1 to the second neighbor's ID. And we repeat the previous steps with the vertex 3 and 5. And if the second neighbor is existing, we will ignore it. And this is the vertex 5. Finally, it will return the second neighbors. This method is to check whether the vertex U can reach the vertex V. For example, we want to examine whether the vertex 1 can reach the vertex 6. To be visited vertex is equal to the UID. In this case, it is the vertex 1. And then we set up real ID as the last item in the list to be visited vertex, and pop up the list. And then traverse the adjacent list of real ID. If the vertex is not 6, and then add it to the to be visited vertex. And then we repeat the previous step with the vertex 3, 4, and 5 until reach the vertex 6, or there are nothing item in the to be visited vertex list. Traverse all vertex and check whether the vertex can reach itself. Return true if the vertex can reach itself to show there is a cycle. For the depth first search, there are two variables, DFS vertices and visited vertices ID. In this case, let DFS vertices equal to the UID and add a UID in the visited vertex ID. Then put them into the depth first search. traverse all adjacent lists of the vertex 1, and then we added 2 to the DFS vertices. And we put the current vertex to the depth first search. After iteration, all vertex has been visited, and we can get all vertex in DFS. This is for breadth first search. It's different from the DFS. For the BFS, we add all the adjacent list of real ID into the to be visited vertex, and then conduct iteration. Outtree is a method that also uses the depth first search. However, during the iteration, the tree will be created and saved, which will be iterated during the process. Finally, it will return the tree. Thank you for watching.